Hello. Today we're going to talk about series. So, when we talk about series, make sure that you understand that a series is nothing but the sum of the terms of a sequence. So, all you're doing is adding up all of your terms together. For a finite sequence with n terms, the corresponding series is the first term plus the second term plus the third term adding all the numbers up until the last term. Remember, u sub 1 is the value of the first term. U sub 3 is the value of the third term. U sub n is the value of the last term or any term. So we can say that the sum of this series is S sub n. That stands for the sum of the numbers or the sum of a certain number of terms is equal to the first term plus the second term plus the third term, adding all the way up until the last term. And it will always be a finite, aka a definite real number. Okay. For an infinite sequence, the corresponding series will be that your S of n, or the sum of all your terms, will be equal to the first term plus the second term plus the third term plus the last term that they give you, but it's going to continue on forever. Okay. So you're going to keep adding indefinitely. Okay. So, quite often, you will see that the sum of an infinite series cannot be calculated. However, sometimes it does converge. Converge means that it's going to get close to a finite or a definite number. Okay. And then we have the sum of a sequence can be written in sigma or what we call summation notation. And the symbol for sigma is the Greek letter E, and it stands for S in the Greek alphabet. When we write when we write our sequences being added together, instead of writing them out where we're just adding, we can just write it as the sum as k goes from 1 to n of u of k. So we can write it as this, u where uk represents the pattern or the sequence expression here. Okay, so when we read it, we know that the sum of u of k, or u sub k, as we go from k is equal to 1 to the last n value of k, it reads the sum of all numbers in the form u sub k, where n is equal to 1, 2, 3, going all the way up until whatever number n is. So let's look at the examples. So example number 1, it says, consider the sequence 8, 1, 8, 27, 64, and 125. It says write down an expression for S of n. So we want to write it in summation notation. So one thing you should notice is that 1, 8, 27, 64, and 125 are all perfect cubes. So what I could say here is that my sum will be equal to 1 to the power of 3, which is 1, plus 2 to the power of 3, which is 8, plus 3 to the power of 3, which is 27, plus 4 to the power of 3, which is 64, plus 5 to the power of 3, which is 125. And what I can do is I can equal this out and write it in summation notation. So I went from k is equal to 1, and I went all the way up to um n, and let me scoot this over a little bit because remember this will continue, so this will be plus, and then of course we know in the pattern that we will continue to do this until we have n to the power of 3. I wanted to make sure I added that part. So that's going to be equal to the sum as k is equal to 1, going all the way up until what I choose my last number or my n to be, and that is going to be written as, the expression is going to be k to the power of 3, because I'm plugging in my numbers all the way up until my nth term, and I know I'm cubing. So now for part B, it says find the sum for n is equal to 1, 2, 3, 4, and 5. So when I say add up those terms, all I want to do is add up the first term for S1. So my first term, the sum is going to be 1. If I add up my first two terms, that's going to be 1 plus 8, which is equal to 9. If I find my sum of my first three terms, that's going to be 1 plus 8 plus 27. And we know that if that's 9 plus 27, that's going to end up being 36. S sub 4 will be equal to 1 plus 8 plus 27 plus 64. So if I add 64, I will get 100. And then S sub 5, which means take all the numbers in S sub 4, and you are just going to add on the fifth number, which is 125. And I know that 100 plus 125 gives me 225. So these are my first 5 numbers. We have 1, 9, 36, 100, and 225. Okay. So now let's look at our last 2 examples on the back. So number 2 says expand and evaluate. So expand means that we want to find each individual term, and then we're going to simplify it and find the sum. So as we can see here, we see that we should be evaluating. We're going from 1, 2, 3, 4, all the way up to 5. So that means that I need to substitute in 1 here. So we're going to have -2 times 1, that's the first k value, plus 3. So that's going to be 1. And then we know we're going to add. I need to find the other term, which is going to be the 2. Plug in 2. So that's going to be -1. So we got 1 plus -1 plus, do the same thing except for we have to plug in 3. So that's going to be -3 plus, do the same things that we find out when k is 4. So that's going to be adding a -5. And then we're going to add the fifth term, which is our last one, which will be -7. All right. So we know that that's how our sum will be. We're adding up all those terms. So that's just going to be 1 minus 1 minus 3 minus 5 minus 7. All right. And when we do that, when we add that, we end up getting -15 as our answer. All right. And you can put that in the calculator if you need to. So now let's look at B. So B is the exact same way. So I'm doing the first 4 terms. So what I need to do here is I need to type in 1 over 2 to the power of 1 plus 1, because the first k value is 1. So that's going to be 1/4 plus, because we're adding, then we're going to do 1 over 2 to the power of 2 plus 1, which will give us 1/8 plus, do the same thing except we're plugging in 3. That will end up giving us 1 over 16. And then we have to do our last 4th term, which will end up giving us 1 over 32. So we will add all these up. So if I were to add 1/4 plus 1/8 plus 1/16 plus 1 over 32, I will equal 15 over 32. So that will be my sum here. All right. So now another way that you can find the sum using the calculator is that if you wanted to, you can put the summations into the calculator. So in order to get that summation symbol to pop up like this, you need to press the math button. You're going to scroll down to 0, which is summation, and then we're going to type it in. So instead of typing in k equals 1, we normally type in x equals 1, because the variable button automatically puts an x, which means we're just putting in x instead of k. So we have the summation as x goes from 1 to 5 of -2 times x plus 3. And as you can see, it gives me -15. All right. If I do the same thing, go to math and then my summation. If I do x equals 1 all the way up until 4 for B. And then I type in alpha y equals 1 over 2 to the power of x plus 1. I get 15 over 32. So I can use the calculator or I can do it by hand. All right. So last but not least, there are some notations that you can use so you can break down or simplify easier. So here it says, if I take the sum of two things being added together, like A sub k and B sub k, if I take the summation of two sequences, it is the same thing as me taking the sum of one sequence and adding it to the sum of the other sequence. So you can break them up and then add them together. The one part in green, it says if C is a constant, if you are taking the sum of a sequence that's being multiplied by a number, for instance here, C, the constant C is being multiplied by the sequence A sub k. That is the same thing as finding the sum of the sequence first. So finding the sum of A sub k first, and then multiplying it by the C after I get done finding the sum. And last but not least, if you have the sum of a constant going from k is equal to 1 to whatever number you want to have it at, it's just the same thing as keeping the number of the last term and you just multiply it by the constant. All right. So if you have any questions, please reach out to your teacher and have a great day.